Welcome to data. You keep using that word, which is another one of the talks about stuff that seems obvious but really isn't. I'm part of the Wix engineering team, which is quite awesome, and we're always hiring and stuff, so yeah, you know where to find us. I'm not going to talk about Wix because, let's face it, it's boring and you all know it anyway. So let's just go right into it. And by the way, I'm Nukenberg on Twitter, if anybody wants to tweet and shit. Yes, and shit. So let's start by defining data. What the hell is data? Well, for something that people use all the time, you know, big data, data-oriented, and all that stuff that you hear about, it's quite bizarre that no one here can tell me what data is. Don't you think? So maybe we should talk about what data is. So I have my own definition of what data is, and I'm specifically saying it's my definition, so we don't, you know, start arguing about this, because I'm right, of course. Data is a representation of information in a computable, storable form, okay? Mainly digital form, okay? And this is important. And this is important because this means that it has some limitations. We can't store in digital form anything that we want. We can't store infinite stuff, for example. So data has to have some finite length, finite size. It has to be discrete, because this is the way digital formats work. This means that we have to make decisions about resolution, for example. We can't store, you know, very fine-grained resolution. It just takes up too much space. Also, it's bounded. Okay, for example, integer has an upper bound, and so on, so on, so on. But the most important thing is that data is structured. Okay, so probably all of you have heard of unstructured data. There is no such thing as unstructured data, not by my definition anyway. Okay, what we call unstructured data usually means that we have multiple structures, or maybe we don't know the structure so well, and so on, so on, so on. But data is always structured in some form. Why? Because computers can only work with structured stuff. And this is why. And of course, it has to have a known format, otherwise you can't use it. Data is a snapshot of information. When you capture data from the world, from the real world, you take it at an instant in time, and the world keeps living on, keeps changing. And the data, that's frozen. That doesn't keep, you know, evolving as time goes by. So it's basically a snapshot that lives on its own now. But now that we know what data is, the question is, how does information become data? There has to be some process of converting information into data. And what is that process? Data modeling. That is a process. This is a process where we take information and we force it into some digital form, like so. This is a process that is, you know, we do it all the time, but we often ignore it. Most people are not even aware they're doing it. So it's really worth taking a look at this, because when you make mistakes in data modeling, those are bugs that are almost impossible to fix. Like, there's really no way to recover bad data, is there? So probably we should talk about this. Data modeling is a process of defining how to extract data from real-world information. And it has a number of parts, and so on, so on, so on. But what we need to understand about data modeling is that data modeling is lossy. There is always some information that we lose in the conversion. Okay? Why is it lossy? First of all, because we have to make decisions about what we don't collect. We cannot collect all the information. We don't have enough space. There's infinite information in the world, and we cannot collect all of it. So we decide up front what we want, what we don't want. Some of that stuff we will never collect. Some of that stuff we might find after the fact that we need, but we didn't collect it, so now we're kind of screwed up. But that's not the only problem. It's also lossy because we have limited accuracy. Remember, resolution and bounds and that kind of stuff. So the conversion itself is lossy. It's not only the decision that we've made about what to collect, it's also the conversion itself. And of course, we lose context. All the information, all the stuff that we have in the world comes in context. And when we extract data, we lose that context. And that means that the data that we took has now a slightly different meaning from what it had in the real world. Data models are always biased. Okay? It's a selection bias, basically. Because we've selected the subset of information, that subset has a bias. Often this bias is not a bias that is up front. We kind of ignore it, really. But it's a bias that exists nevertheless. There is some reason why we collected this data and not this data. Usually it's because it's easier. And that's a fundamental bias that can hurt us really bad. But the conversion itself, again, is also biased. And I will give an example of this. So formats, okay? There's an assumption that the format in which you store the data doesn't impact the data that you have, right? That's kind of an implicit assumption. This assumption is incorrect. Formats have a huge impact on the data that you collect and on the type of conversion that you use, okay? One of the very frequent examples that people see is JPEG and PNG. For example, PNG is an image format that can be used for text, and JPEG is a picture format that cannot be used for text. And why? Because JPEG, the compression algorithm that we use in JPEG, doesn't work very well on sharp edges. Okay, so if you try and scan something, text, and save it as JPEG, you would have these artifacts. You would have dots around the stuff. You will lose the edges of the fonts would look bad. The font itself will be bad, and in some cases will be unreadable. You have lost information in the conversion. Okay? But a lot of people are not aware of this, and you would be amazed how many OCR programs have as a default format JPEG, which is horrible. JPEG is awesome for pictures, for scenery, for that kind of stuff. But if you think about this, even when you take a picture, you have some bias and some loss, because you have to have focus. Cameras have focus, and if you focus on the person, you lose the background. If you focus on the background, you lose accuracy on the person that you're taking the picture of. Okay? So you have all those phenomena all the time. But if that's not bad enough, the rest of the conversion process also have problems. So let me tell you a story. This is a story about the Xerox photocopiers, specifically the Work Center model. And this QR code here is a link to the original blog post of the guy who found this. And basically, when you take a picture in a photocopier, when you copy a document, you expect the copy to be, well, a copy, right? Well, you'd be amazed. This is what actually happens. You take a picture, and some numbers and some letters are being replaced. They're not being smudged. They're not being distorted. They're being replaced. Okay, you can see here that the 8 here was originally a 6, and here. This happened in legal documents, on architecture plans, and so on, so on, so on. And what did people do with the original? Well, the copy is, of course, a copy, so they threw away the original. Now, there's no way to recover from this. This has been in the field for 8 years. 8 years. Imagine the amount of data that we've lost. And why did this happen? This happened because, well, a photocopier is basically a scanner and a printer attached. And they scanned, and they saved in a picture format that had pattern matching to save space. And it matched patterns very well, as you can see. They didn't use lossless compression, which they should have. So yes, formats do matter. And you need to think about the intent of how you're going to use that data when you extract that data, because it has a real impact. So let's, as an exercise, try to model a person, okay? And let's see if we can find all the problems that may arise in this modeling. So let's talk about names. Every person has a name. Yes, you all know the reference to this. Of course, they have a first name and a last name. Sometimes they have a middle name, maybe. But how long should the name be? I mean, we have to have some limit in the database, right? Should it be 10 characters? Should it be 20 characters? Is that enough?
No, 10 is not enough.
What, sorry?
10 is not enough.
Not enough. Let's give an example. So this is the longest name in Africa. I don't know if you can hear this.
My name. Yes, your name.
This is his name. I don't know if you can hear this, but look this up online. It's hilarious. And you can see the frustration on that person's face when he keeps repeating the name, and the guy doesn't get it. Very, very annoying. This is actually not the longest name in the world. This is. Senior, yes. By the way, does anyone know Picasso's full name? So Picasso's full name is Pablo Diego Jose Francisco de Paula Juan Nepomuceno Maria de los Remedios Cipriano de la Santísima Trinidad Ruiz y de Picasso. That's Picasso's full name. Yes, 10 characters is definitely not enough. Of course, some people don't have middle names, some people have middle names, some people don't have last names. Not all cultures have last names, for example. And of course, in some cultures, it's not clear if the family name is first or last. Is Kim Jong-il Mr. Kim or Mr. Un? Anybody want to take a guess? Mr. Kim, that's correct. He's Mr. Kim, he's not Mr. Un. In Korean cultures and many other East Asian cultures, the family name comes first. So you can imagine what happens on forms and how the data gets distorted in that conversion. That doesn't work very well, does it? Names are hard. There's a lot of cultural differences. They can change. People don't take this into account. You can change your name. We have legal names and we have names that people go by. Not always people have one name. Sometimes they use different names. The Chinese, for example, have a Western name and they have a Chinese name because the Westerners can't deal with the Chinese name, obviously. Some names are not Unicode. Like, I thought that ASCII was not enough. Turns out that even Unicode is not enough for names. By the way, the QR code, again, gets you to a very, very interesting article about all the falsehoods that programmers believe about names. Minimum length and maximum length. So my friend Oz here tells me that he has a lot of problems in the US because apparently the Americans think that names with 2 characters don't exist. Yeah, that's stuff. So lots and lots and lots of problems. Age must be so much easier, right? But age changes every year. Unless you're a dead person and then it doesn't change anymore. Okay? What about the minimum and maximum age? So it turns out that in Korea, when you're born, they start counting from the moment of inception. So when you're born, three months after you're born, you're 1 year old. Whereas in the rest of the world, it's like 0, and in China, it's 1 immediately. Okay. What happens if you were born on December 31st, midnight? And then the time zone changes. What's your age? Well, apparently you're 1 year older. And why is age an integer? Why isn't it float? We've made a decision about resolution, but like, why? Okay. The result of all of this is that people have weird bugs. An example is that a 114-year-old woman tried to register on Facebook and had to lie about her age because apparently Facebook don't believe that people over 100 exist or would ever register to Facebook. Yeah, they fixed it since. But yeah, they had this problem. Look this link up. It's hilarious. Yeah, so many problems. What about gender? So if you're talking about physiological gender, then 4 genders exist. You either have male genitalia, female genitalia, both or neither. Okay? So 4 genders. Definitely not binary. What about social gender? You're talking about maybe 26 or something like that. But if you're talking about legal gender, then you only have 2 in Israel because our government doesn't believe physiology or something. Whole reality in general, but let's not go there. Anyway, it's definitely not binary. So it really depends what is the purpose when you're talking about gender. What about addresses? Like, we've made the addresses up, right? There's no reason they should be complicated. Does everyone have an address? I was a nomad for almost a year, for example. I didn't have an address. I had to put an address on some forms because like the government doesn't believe that people like me exist, but I didn't actually have an address. What about zip codes? So in Israel, we changed the zip code from 5 digits to 7 digits, and that created whole lots of problems for many old systems. But it turns out that in some countries, the zip code is alphanumeric and not numeric. Okay, military addresses is a good example here in Israel. Also, we have other problems with zip codes. Some buildings have 2 zip codes, some have none. Addresses can change. Maybe because I moved an apartment, or maybe because the city decided to change the name of the street. They do that, apparently. Or maybe the country changed its name. That also happens, right? So very, very, very quickly. By the way, I found out that you can have a building with a negative number. Yeah, that exists. I don't know. What about countries? So when you're talking about country, it depends when. So think about former Yugoslavia, for example. Don't get me talking about Yugoslavia. Like everything there is messed up. But like Czechoslovakia used to be one country, now it's two countries, and one of them changed its name. Like it used to be like the Czech Republic, and now it's just, I don't know, Czech or something. So really, really weird. So it depends when, but also who you're asking, because if you talk about Taiwan, for example, the Chinese will tell you it's China. The Americans will not agree. And you can go on and on and on with this. It's really, really problematic. What about identity? A person has an identity. How do you distinguish between two people that live on the same street and have the same name? That's a problem. Fortunately, in Israel, we have an ID number. What about countries that don't have government-issued ID numbers? Or maybe they just don't want to give you the ID number. And you can't force them, can you? Unless you're the government, and then you don't care. Yeah, that's hard. Let's talk about dates. Dates are insanely hard, insanely hard. First of all, we have multiple calendars. We have the civil calendar. We have the Gregorian calendar, which is just like the civil calendar, but it's not. It's different. And then we have the Jewish calendar, which is moon-based, but we adjust it to the solar calendar. And then we have the Muslim calendar, which is totally moon-based. So it kind of, moves around all the time. It's really weird. But then we have like the Chinese calendar and so on, so on, so on. Really weird calendars all over the place. Really, really hard to work with dates. Even if you're working only with a civil date, you have to deal with stuff like time zones. And time zones are horrible. They're horrible. They start and end on different dates every year on different countries, okay? And sometimes the government announces it like 2 weeks before, or not even that. The zones themselves change. Some countries just move themselves between the time zones. Sometimes you have in the same country different zones. Sometimes the country, I don't know if you know this, but you have zones that are like on the half-hour marker and not the full hour. Really, really weird. They can geographically overlap. You can have the same time zone in the same place, two different time zones in the same place. An example of this would be East Jerusalem. The Palestinians have their own time zone, and we have our own time zone, and it's the same place. I don't know how it even works. And of course, some dates don't exist, because you skip an hour, and then this hour doesn't exist, but then you have an hour that exists twice. Okay, that sounds fun. You might want to check this, look it up on YouTube, Computer-Fired Time Zones, 5-minute video, really hilarious, and yeah, lots of problems. So obviously we want to use UTC, we don't want to use time zones, but that in itself has a lot of other problems, because if you only use UTC, there are fundamental questions you cannot answer without additional information. For example, was it day or night? Well, I don't know. Depends where on the planet. What day was it? Was it Tuesday or Wednesday? Again, depends where it was on the planet. So UTC is not enough. Okay, maybe we have to store both. But time itself can go wrong. Okay, it's not only time zones. People assume that we have 24 hours in a day. That's not true. We can have 25 or 23. But we don't have 365 days in a year because we have the leap year. But then we have the leap second, so every once in a while, every few years, we have 61 seconds in a minute. Time, of course, is not infinite, as we found out in the Y2K bug, because no one thought that 100 years would pass. Actually, it was more like 20. But actually, the clock itself can, jump forward and backwards, because we sync clock all the time. That creates a lot of problems. So time is not as simple as people assume. Numbers is one form of digital storage, okay? And in a computer system, we can store integers, we can store floats, we can store signed or unsigned numbers. We can store, of course, every number has a resolution. The resolution of an integer is exactly 1. And each number has a bound, okay? You cannot store infinite numbers in a computer, of course. So ints, for example, so integers. So this is how an integer would behave. For example, I have an integer, I've set it to max int, and as you can see, it's above 0, but when I add 1, it's suddenly below 0 because it overlapped. This is a phenomenon that happens in all computer systems. Some runtimes work around this automatically, some don't, and this can happen all the time. This creates a lot of problem when you model data on integers. So we might be tempted to use floats for most stuff, but they have problems of their own. When you do this, for example, you get this weird result, which is inaccurate. And of course, most of the time we don't care because it's a very, very, very tiny difference, unless, of course, we're dealing with money, as you've seen in open space. Tiny fractions of a cent can add up to a lot of money. And if you use money, you don't want to do that because money cannot overflow ever, ever, ever. You don't want to get your salary and then suddenly owe the money a lot of money, owe the bank a lot of money. And of course, it shouldn't have rounding errors because then someone loses and someone gains money out of thin air. But things that convert to money can be float, and you have conversion errors because of that. So really, really complicated and annoying. If you actually write software for money, use big decimal for money, otherwise you will have lots of problems. So what do we want to do? We want to learn how to do data modeling properly so we can avoid all of those problems. First step in doing data modeling is to remember that we store facts. We do not store relative data. We want to store stuff that is absolute, that does not change in time. A fact is absolute data. For example, birth of date is a fact, whereas age is not. Age is relative. And new facts can be added. For example, if you're dead, I will add a new fact that is the date of your death, okay? And then I can compute everything from that, okay? Every fact has to come with the timestamp of when it was true. I want to use extensible formats and extensible data types, of course, because I can keep adding up more data, and of course some data might be missing, maybe because there's data I haven't collected, or maybe because of other reasons. Maybe someone didn't want to provide that data, or maybe it's a new field. Okay? I need a way to express missing data. I want to store metadata so I can debug the data. So examples of metadata that I want to store is the date of collection, the software version that I've used to collect the data. For example, if I have problems, I have weird data, I go back to the software that collected, I look the version up. Sometimes I find that maybe the form was bad, or maybe it has a misleading question, and so on. Okay? I want to make sure that I know how it was collected, by whom, okay, which person or system entered the data, and so on, so on, so on. First step, predefine intended usage. This is why our example before was bad. We didn't define what was the purpose of the modeling. Was it an HR system, in which case we care about legal entities? Or was it a social network, in which case we care about the social constructs and so on? How are we going to use it? Okay? And of course, we might store multiple versions for different use cases. For example, we could store family name and first name and the full name, in which people can just enter whatever they feel like. Okay? Because it's for multiple purposes. And that makes sense. Second step. Select the subset of information that you need. Think about what you need and what you don't need. Make a very, very explicit decision about this and document why, because this might change as you gain more information about the business. Define the constraints. We have constraints that are digital. We have physical constraints. We have a lot of other constraints. Define them. What should be the resolution? What should be the bound? And what data type should you use? And then finally, define the collection method. How are you going to convert this information? Are you going to use a form? Are you going to use a digital to analog converter? Are you going to use a camera? How are you going to use the camera, and so on, so on, so on? Is the conversion lossy or non-lossy? The format can be lossy or non-lossy, and so on, so on, so on. You have to take into account that in any conversion there are artifacts. So think about the possible artifacts that can arise from the conversion. And make sure that the collection method is versioned, okay? Because it might change in the future, and you want to be able to track that. Select a compatible data type for storage, okay? It can be a universal data type, and it could be a specific data type. For example, dates, if you store them in a string, okay, this is a universal data type. But then you have to have a secondary format, usually ISO 8601, which tells you how to read this string and convert it into a date that you can actually use. Remember again, there can be possible artifacts to the format. PNG and JPEG is a good example. And this, of course, should be versioned. Okay, so we'll skip that, but if anyone will want to look after in the slides and see an example of how we model better, then that'd be awesome. There's a QR code and a link to a GitHub repository online that is very, very good. Thanks, Oz, by the way. Which contains a lot of articles about falsehood in data and falsehoods that programmers believe about stuff. Really interesting read, very hilarious. I highly recommend it. Okay, go have lunch. Thank you.